Hey, welcome to iFlip for Math, Mathcast number 1. I'm Mrs. Gooding, and our lesson tonight is dividing whole numbers with different types of remainders. Our quote is by Jane Goodall. She said, if you really want something and really work hard and take advantage of opportunities and never give up, you will find a way. And I do believe that it's the same way with learning new math skills. If you really want to learn them and you're not afraid to practice a lot and you watch videos to help you learn new concepts and get help from your math teacher when you need it and just never give up, you will find a way to be successful in math. And I think that's exciting that if we do those things, then it's really just going to be a matter of time before we figure out what we need to learn. Our learning goal tonight is to use 3 different types of remainders when dividing whole numbers. There's some pictures of Jane Goodall. She was a researcher of chimpanzees, and you guys know how much I like orangutans, but Birute Galdikas, who was the researcher that I like to follow of orangutans, worked with Jane Goodall, and they worked for a guy named Louis Leakey, and he helped them to develop some really great research that helps us to understand the apes better and also to understand ourselves better. So she's really exciting to read about, and there's books at every level written about her research with the chimpanzees. Our individual lesson learning goal tonight is to divide whole numbers with remainders using the standard algorithm. We're going to show the remainder in 3 different ways. We're going to show the remainder as a typical remainder. You can see that example when we use the lowercase r, remainder 2. We're going to show the remainder as a fraction, really just written as a fraction. And we're going to show the remainder as a decimal amount. So 3 different types of remainders, and we're still just dividing whole numbers. There's a picture of Jane Goodall when she was young and began her research with chimpanzees. Our vocabulary tonight is similar to vocabulary that we've had in the past. So we're talking about a quotient. That's the answer to a division problem. The remainder, no matter how we display it, how we present it, is always the amount that is left over after we're done dividing. So, for example, in the regular remainder style, we write R2, remainder 2. The quotients are represented in blue in all of these vocabulary terms. A fraction, that represents parts of a whole. Remember that a fraction always has a value less than 1. So you can see the fraction amount there in purple, 1/2. And a decimal is a number that uses a decimal point followed by digits that show a value less than 1. Both fractions and decimals are always going to fall between 0 and 1 on a number line. So you can see that example there with the quotient in blue, 4, and the decimal part of the answer, 35/100ths, in purple. Here's our first example, 384 divided by 20. You can see some of the chimpanzees that Jane Goodall built a relationship with. She interacted with them quite a bit, and they grew to trust her. She was also in National Geographic magazine. Way back when, I have a copy of her magazine from the 1960s or 70s, I believe. So let's go ahead and show the different ways that you can use remainders when you're dividing 2 whole numbers. So we're going to divide 384 divided by 20 using the standard algorithm. So we start out with 20 goes into 3, and it doesn't because you can't go into a room that's smaller than you. And then we'll do 20 goes into 38. So we just made that room just a little bit bigger, and it goes in 1 time. So 20 times 1 is 20. Then we'll subtract. 8 minus 0 is 8. 3 minus 2 is 1. And we will bring down. Make sure you draw your, oops, that was terrible. We'll pretend like that's not there. 20 goes into 184. And just modeling some mental math strategies for you, I know that 20 will go into 100 5 times, and 20 goes into 80 4 times. So 5 plus 4 is 9. And 20 times 9 is 180. Subtract that, and I get 4. This is what we would usually call our remainder 4. We would write it like this. And that's the regular remainder way of displaying that quotient with the remainder. Now I could also display that as a fraction by writing 19, just like it was. And then instead of writing 4 with the remainder r, I can write 4 as the numerator in a fraction, And then my denominator is always my divisor, which is 20 in this problem. 19 and 4/20. Because every night we have 19 groups of 20 in this quotient, and we have 4 left over because we don't have enough to make another group of 20. So I have 4 of the 20 needed to make another group. Now, I would want to simplify that. So that would mean I would have 19 and 4 divided by 4 is 1, and 20 divided by 4 is 5. So the fractional way to show that answer would be 19 and 1/5. So we've showed it to you now with a regular remainder and with a fractional remainder, and those are both worked using the standard algorithm for dividing whole numbers and displaying them as just a regular remainder. Let's go ahead and delete some of that so that I can show you what it would look like if we were going to have a decimal answer. I'm going to actually write that fractional remainder down here so that we can see it. And I'll also put that remainder 4 that we had for our regular remainder. Now, when I'm dividing a decimal, when I get to that point in the division problem where I say, do I have any more numbers to bring down? And I do not. And I ask myself, do I have a roof over every room in my house? And I do, whether it's an X or whether it's a part of the quotient. Remember that a remainder can't be part of the roof over every room in the house, but we can go ahead and then add a decimal to the end of our dividend, just like this. And what that decimal says is that we're going to use a different method to finish displaying the remainder in this problem. I'm going to take that decimal straight up into my quotient so that I have 19 and then my decimal. Everything after the decimal is a remainder, but it's a different way of showing it. Now that I have a decimal here, I can add another room to my house. So I'm going to add a 0 inside my house as an extra room, and I'm going to bring that number down crazily. And now I have the number 40. And 20 will go into 40. It goes in 2 times. 2 times 20 is 40. And when I subtract, I get 0. So since I have no amounts remaining down here at the bottom, I know that I'm done with my division process. I don't have to annex any more zeros or add any extra rooms. I'm simply done. I have no more numbers to bring down. I have a roof over every room in my house. So now, 19 and 2/10. What I want to show you now is that we have a remainder of 4. 19 with a remainder of 4. We also have 19 with a remainder of 1/5. Now, 19 and 2/10 looks like it's completely different numbers, completely different. And yet, it's actually the same amount. Let me show you how I know that. If I were taking that 19 and 2/10 and writing it as a fraction, I would write it like this. 19 and 2/10, just like I read it as a decimal. Well, 19 and 2/10 can be simplified. We'll rewrite the quotient 19. And then 2 divided by 2 is 1, and 10 divided by 2 is 5. Now look, 19 and 1/5. So 19 and 2/10, or the decimal 19 and 2/10, is equivalent to 19 and 1/5, which is our fractional answer. And that's one thing that I really want you to understand about the different ways that we represent remainders. Even though you have different numbers and they look like different amounts, they are actually representing the exact same amount. It's kind of like if I were speaking 2 languages. If I am speaking English and I ask you to show me the value of 1, you would show me this, the value of 1. That's the amount 1. If I were speaking Spanish and I ask you to show me the amount of uno, you would show me this, the same amount. And yet we use a different word when we're speaking different languages to describe that amount. We wouldn't use that same word from both languages at the same time. We wouldn't say, show me the amount 1 uno. We're either speaking the language of English or we're speaking the language of Spanish. In the same way, we're speaking the language of remainders as remainders, we're speaking the language of remainders as fractions, or we're speaking the language of remainders as decimals. They may look like different amounts, but they are actually just different ways of representing the same amount. And That's kind of exciting to know. That's something a lot of fifth graders don't understand, and it's something I'm not sure even I understood until I was older. So you're going to have a head start. Let's go ahead and work some more problems. Here is practice problem number 1. Now that you've watched how to do it and written it down in your flip journal, go ahead and use that example to help you figure out how to solve this problem. Work this problem and show the remainder as a typical remainder, a fraction, and a decimal. The problem is 628 divided by 25. Pause it, work it in your flip journal, and then go ahead and push play, and I'll show you how we did that one. So now we're going to work the problem 628 divided by 25, and we're going to begin working it just like we would any division problem. So 25 goes into 6. It doesn't. You can't go into a room that's smaller than you. So we're going to make that room bigger, 62. 25 goes into 62 2 times. 2 times 25 is 50. Oops. 2 minus 0 is 2. 6 minus 5 is 1. Bring down the 8. And you know I always tell you to draw those bring down arrows so that you can keep track of whether or not you've actually brought a problem down, a digit down. Now we have the number 128. And I know that 25 will go into 100 4 times. It goes into 28 1 time, and 4 plus 1 is 5. So I'm going to multiply 5 times 25, and I get 125. When I subtract that, I have a remainder of 3. And we can write that as 25 remainder 3. That's the regular way to represent our quotient with its remainder. Now, I can also take that same problem and write it as the same quotient, 25. And then instead of writing that remainder, remember, I can write the 3 as my numerator, and the divisor is 25. It will always be my denominator, because I have 25 groups of 25. I don't have enough to make 26 groups, the 26 being up here in the quotient, because I only have 3 of the 25 needed to make another group. So I have 3 of 25 needed to make another group, or a remainder of 3. Now let's go ahead and solve this speaking the language of decimals. So we're going to totally change over into the decimal language. To do that, we need to make sure that we have a decimal in our dividend. If there isn't one there already, we can always add that invisible decimal that is at the end of every whole number and take it straight up into our quotient. Now, after that decimal, I can annex as many zeros as I need to, one at a time, in order to solve my problem. So I'm going to annex my first 0 and bring it down. There, that's great. There, I've brought my 0 down. Now I have 25 goes into 30 1 time. 1 times 25 is 25. 30 minus 25 is 5. Now I still have a remaining amount, even though I have no more numbers to bring down in my dividend, and I have a roof over every room in my house. So I'm going to build another room, or as we say in math language, I'm going to annex another 0. And I'm going to bring it all the way down to that 5. I now have 50 down here. So 25 goes into 50 2 times. 2 times 25 is 50, and 50 minus 50 is 0. So I have no more numbers to bring down in my dividend. I have a roof over every room in my house, and I have no amounts remaining here at the bottom, which means that I'm ready to represent this as a decimal answer. 25 and 12 hundredths. Now, to write 25 and 12 hundredths as a decimal, we write it just like this. But we could represent it as a fraction by writing it just as we say it. 25 and 12 hundredths. Now, that looks, it's equivalent. They both have 12s as the remainder here, the decimal part, and the numerator of the fraction. But I can simplify that amount. And 12 actually can be divided by 2, first of all. I'll rewrite my quotient. 12 divided by 2 is 6, and 100 divided by 2 is 50. And you're right, I can simplify that even more. So I'm going to rewrite my quotient 25. And then 6 divided by 2 is 3. And 50 divided by 2, did you guess it? You're right. 50 divided by 2 is 25. So this decimal, when I convert it to a fractional amount, is 25 and 3/25, which is the same as when I converted my remainder into a fractional amount. 3 different ways of representing a remainder, speaking different languages, and yet they all are representing the exact same amount of leftovers. So here are some more pictures. These are more recent pictures of Jane Goodall. And this is one of the things that she has been quoted as saying that's just my absolute favorite. What you do makes a difference, and you have to decide what kind of difference you want to make, whether you're going to be a positive difference in this world or your community or your family or your classroom, or whether you want to be a negative difference in all of those areas. And I hope you choose to make a positive difference. Jane Goodall chose to make a difference with something that really interested her and became her passion, and that was chimpanzees. And Disney Nature has a feature film that you can watch to learn a little bit more about it. Practice question number 2. Work the problem, 406 divided by 5. Show the remainder as a typical remainder, as a fraction, and as a decimal. Go ahead and pause it, do that work now, and push play when you're ready to go over the answers. So I've written the problem 406 divided by 5, and we're going to begin in the regular way. 5 goes into 4, doesn't, so we'll put an X over that. We'll make the room a little bit bigger and look at 40. 5 goes into 40 8 times, because 5 times 8 is 40. And 40 minus 40 is 0. Now we're ready to bring down the 6. See, my arrows are so much nicer when they're short than when they're long. 5 goes into 6 1 time. 1 times 5 is 5. 6 minus 5 is 1. So I have no more numbers in the dividend to bring down. I have a roof over every room in my house, but I still have a remaining amount that I could write as remainder 1. So let's write that down here. I'm learning. 81 remainder 1. We could always write it as a fraction. Do you remember how to do that? Did you write this correctly in your journal? 81, and the numerator is the remainder, and the denominator is the divisor. 81 and 1/5. So now I can go back and speak the language of decimals and solve this with a decimal remainder. I'm going to do that by adding that decimal right after the whole number, at the end of the whole number, and then bringing it straight up into the quotient. So now that I have a decimal there, I can annex as many zeros as I need to, one at a time. So here's my first 0, and I'll bring that down, not too bad. I now have the number 10, so I'm going to do 5 goes into 10 2 times. 2 times 5 is 10, and 10 minus 10 is 0. I have no more numbers to bring down. I have a roof over every room in my house, and I have no remaining amount here at the bottom. So my final answer in decimal form would be 81 and 2/10, which sounds just like it sounds when I write this as a fraction, 81 and 2/10. That's the fractional way to represent that decimal amount. And I can simplify that to 81 and 2/10. 2 divided by 2 is 1. 10 divided by 2 is 5. And I'm not using the cake method to show you how to simplify in this case, because you can go back and watch those lessons in the videos. And I want this time to be focused on how to represent those remainders. So you can see, if we look at our fractional amount or a decimal amount, 81 and 2/10 is equivalent or equal to 81 and 1/5, which is equivalent or equal to 81 remainder 1. It is all representing the exact same amount that is left over. Let's go ahead and go to the next problem. So instead of doing a challenge problem where you're going to be working out a problem, I want you to do something just a little bit different. In your flip journal, I want you to give some real life examples of when you might use division, and it would be helpful to show your division answer as a typical remainder, Another example of in real life when it would be best to show your remainder as a fraction, and another time when you would want to show your remainder as a decimal. Come back tomorrow to class and be ready to share your answers. I think we're going to have some really great conversations, and you'll see how we would use different types of division answers to represent real life situations. This is important because when you're given a word problem, you want to know, do they want to know how many are left over? Just what is the remainder? Or do they want to know a fractional amount? I won't give you an example of when they would do that, but there are times in real life we would want a fractional amount. And then there are also times when we would want to see it as a decimal, and I want you to make that connection and come up with lots of great ideas and share them with your friends. So let's go on to our finishing up. Go ahead and review your learning goals. Have you mastered all of them? Were there parts of it that were hard for you that you might need to go back and rewatch? Or maybe you need to write those questions down in your journal so that you can come into school tomorrow and ask me. You can always email me and ask me too if you don't have me in class. Remarkable remainders. You have completed MathCast 1, dividing whole numbers with different types of remainders. I can't wait to see you tomorrow.